Hello everyone. Today we will be learning on sampling theorem. The question will be asked like this, state and prove sampling theorem. Before learning sampling theorem, let us know what is sampling. In earlier video also I have explained about analog to digital conversion. Analog to digital conversion, there are mainly three steps: sampling, quantization and encoding. Sampling is the first step in the process of analog to digital conversion. Now, sampling theorem statement, many different study materials you might have seen different statements, but all the statements meaning is same. In a very simple way you can remember the sampling theorem. One equation you have to remember, which is that equation Fs greater than or equal to 2W. You remember this equation and let us now define the sampling theorem statement. When we sample a signal at the rate Fs greater than or equal to 2W, we can completely recover back the signal. Here signal means continuous time signal, that is nothing but analog signal. For the sampling we are giving analog signal as a input. See, very simple, you remember this equation Fs greater than or equal to 2W. When we sample a continuous time signal at the rate Fs greater than or equal to 2W, we can recover back the continuous time signal properly. That is the sampling theorem statement. Here what is Fs? Fs is sampling frequency and W is the highest frequency of the analog signal. Our analog signal is nothing but a continuous time signal. What is the highest frequency of the analog signal? Let us see some example. Example, telephone voice. It is an analog signal, telephone voice. Telephone voice consists of frequency component 300 Hz to 3.4 kHz. Here 3.4 kHz is the highest frequency component, 300 Hz is the lowest frequency component. In this case, we have to sample a signal 2W. W is 3.4 highest frequency component, 2 into 3.4 kHz we have to choose as a sampling frequency. One more analog signal example we will take, music signal. It is an analog signal, continuous time signal. For example, one music signal frequency component we have 500 Hz, 2 kHz, 8 kHz and 15 kHz. In this highest frequency component is 15 kHz. Hope this sampling theorem is clear to you people. Now let us see various types of sampling. We have three different types of sampling: Nyquist sampling, it is also known as right sampling, undersampling and oversampling. First let us see what is Nyquist sampling. It is also known as right sampling. When the sampling frequency is equal to 2W, Fs is equal to 2W, it is called Nyquist sampling or right sampling. When we sample a signal at the rate Fs is equal to 2W, we can completely recover back the signal properly without any noise. And this is the spectrum for this Nyquist sampling. Now let us see undersampling. What is undersampling? When we sample a signal at Fs less than equal to 2W, then it is called undersampling. When we do the undersampling, there will be an aliasing effect. So the spectrum we can see here, when we do the undersampling, there is a overlapping of signal. So we cannot properly completely recover back the signal. There is an aliasing error occurs. Aliasing effect or aliasing error occurs during the undersampling. One more type is oversampling. When sampling frequency is greater than 2W, then it is called oversampling. When we see the spectrum, when there is a oversampling, we can completely recover back the signal properly. But this oversampling requires more bandwidth because there will be a guard bit in between. But we can recover back the signal properly. Hope sampling theorem and types of sampling is clear to everyone. Thank you.